There we go. Thank you.
So quick.
Sorry.
Oh, I got your.
That's what you requested. Very, very light.
I don't have enough.
I love all this. What's that? Just in general. Just in general. I'll eat black olives just on their own.
Yeah, they taste really good.
You have to figure it out.
How's it going? Hello again.
Are you going to be doing the talk today?
The what?
Are you going to be doing the talk today?
The top?
Yeah. Should scores my password.
And if I'm lucky, I'll get pizza. Ooh, bad.
Looks like there's 20, so. Looks like there's 20.
Yeah. Awesome. Sick, are we done?
I like something up on the screen for 2 seconds.
What you got? No, thank you. Maybe at the end.
Where do we throw the pizza boxes?
Well, if it were my
Just
talk,
leave it there for now.
but
Of course.
Is there a better
I
place
think
to put
this
them?
would have made some more sense to put up during your talk.
You can just leave it there for now. We can just throw it out at the end. Perfect. All right, we're gonna go ahead and get started. Thank you everyone for coming. My name's Peyton. I'm a, I don't know, graduate student I guess now. Feels weird, but I'm gonna do my talk over operational technology security, which is a really cool topic that more people should know about. Everybody signed in, right? Cool, thank you for doing that. That's how we get our pizza money. So let's start with industrial control systems. Think grids, factories, conveyor belts, all of that jazz. Do y'all think they're hackable? Do you think someone can hack it? You're right. About 10 years ago, most people would say no. But, as all these articles say, water supplies have been hacked. Lights that are used in plane runways have been hacked. Another water supply attack. Saudi petrol plant was attacked. The Ukrainian grid has been attacked multiple times. And even a nuclear power plant has been attacked. So, it is hackable. But why do we care? What is the actual impact that could be caused by all of this? Well, our hospitals could be affected to where services could be lost and people could die. Or even our own water towers, our water plants, we could lose water supply. Our grids could be shut down, leading to catastrophic effects. Our factories that produce key components for our nation or for other nations could cripple, hurting our economy. And last, our energy systems, including our nuclear plants, could sustain physical damage. So let's get into what all this for these factories. So as these ICS systems and components are evolving, the gaps separating these OT and IT systems are basically non-existent. So let's talk about what actually the components are of operational technology and what makes up operational technology. The main tool that is used that if you ever go into this field is the Purdue model. and it's going to be a high-level architectural view of what operational technology looks like. There's 5 levels, and or 6 levels, because we start from 0. We're computer scientists. And the top levels are going to be your IT level. This is going to be your enterprise and the firewall that's connecting to the operational technology. And then your lower level is actually your operational technology level, and that's going to be the meat and bones that is going to be allowing this to happen. So the different kind of components that are part of operational technology are your sensors and actuators. That's your level 0. Then your controllers, they're going to be controlling your sensors and actuators. Then your local supervisory systems, they're going to be controlling your, they're going to be controlling the things that are controlling the sensors. Then your management systems, which is a higher level. And last, you've got your business system, which is what we generally think of as IT. So we're going to start from level 0. And again, at this level, think components. You have valves, switches, conveyor belts. These are the things that are actually physically moving the boxes. They're actually controlling the water flow, or they're measuring chemicals or so on based off of the factory's need. Now, they're going to perform the process, and as we're modernizing, you'll notice that a lot of these sensors, switches, actuators are starting to become smarter. They're having more built-in features that allow you to program it straight from the sensor and have an internet connectivity, which also leads to more ways of them being able to be attacked. Sometimes these are connected with the next level, the process level, because a lot of these sensors and actuators are smart and they're able to be controlled by their own device instead of being controlled by another device. So the next level is local controllers, and this is what I think is a really cool part. These are the tools that are, or the boxes that are actually making the switches make the change. And the main thing that they're using is called a PLC, which is a programmable logic controller. This is a box that you can think of that's going to sit on a factory floor, and it's going to have code written into it to where it'll say, all right, the water temperature is too high. I'm going to change this one thing until the water temperature gets lower. And it'll send that electrical signal to the thing that controls water temperature so that it meets the demands that is specified in the code. And the cool thing about this is the code is weird. Most of us are computer scientists, I assume, or in that area, and you're used to like C, Python, JavaScript. Makes sense. Well, in this, they use something called ladder logic, which is like a weird electrical diagram that people use blocks, and it's kind of like building a Lego set to be able to write your code, and it makes no sense to me. There's also a function block, which is essentially the same, except it's less ladder and more blocks that you connect together using lines. Think about if you've programmed in the Unreal Engine, they have the block programming. I don't remember what they call it, but it's like that.
Is it like Scratch?
Yeah, it's kind of like Scratch, yeah. And then last, there's your functional, your structured text. And your structured text is more your assembly, where you're actually looking at the lower level commands. You're manipulating the memory, and you're manipulating functions in a more procedural way. Besides the PLCs, which is the brains of all these tools, all of these sensors and actuators, you have your remote terminal units. And your RTUs, or remote terminal units, is essentially a computer that's going to be directly hooked into your PLC. That's going to be usually on the factory floor, or there's going to be a connection to it from the factory floor, where you can show up, touch the iPad, or type in some code and make any changes you need manually. Oops. Then we've got level 2. This is where the majority of the hacks are occurring, is in level 2. Now, in level 2, this is you can think of it as a network that's connecting all the different PLCs together and doing the overall monitoring of a specific floor or process. So if we have a factory floor and its goal is to process, let's talk about UPS. Its goal is to receive a box, figure out where it came from, and then where it goes. You're going to have one SCADA system usually that is controlling that entire line, and it's going to be talking to all the different PLCs that are going to tell that are doing all that function, all that logic to figure out where those boxes go. And it's essentially, in the old days, it was using a lot of proprietary and a lot of not open source protocols to make that communication between the PLCs. But now the majority of them are using Ethernet, which is a very common protocol that is used in basic networking at our business levels, which means that it is susceptible to a lot of the attacks that are used on our business networks, which I'll get into more later. There's two main types of control systems at this level. The one that the majority of companies are using nowadays is called SCADA. And SCADA is a program or protocol that is used to connect these networks. It is focused more on high-speed communication and doing it fast, and it uses Ethernet so that it's a lot more convenient and it's a lot more accessible for the majority of businesses to use. On the other hand, in the older days, a lot of these companies were using DCS. DCS stands for Distributed Control System, and this is essentially does the same thing that SCADA does, but it's not as fast, but it is way more reliable. So if you're wanting to be safer, then you would use this. It also is going to contain more proprietary technology. It doesn't use Ethernet for its communication protocol, which means that you are going to have more issues. You are going to have less, it's going to be more work to hack it. Again, there's more HMIs that are connected at this level. HMIs are essentially the iPads that are used to control every PLC, turn them off, turn them on, access them if needed. And yeah, that's good enough. Something that I do want to talk about here actually is that if you, like a good network, if you have a bunch of different processes, or if you have a bunch of different things that are going on, you don't want them all connected to each other, because if you are able to access one and compromise it, and it's connected to this completely unrelated conveyor belt line or this completely unrelated SCADA network, then that's just going to make it a very easy jumping off point for these hackers to get into it, which we'll talk about more later. But make sure these processes, if they're well designed, will be letting your IT directly connect to your operational technology. Then you're letting your accountants and your desk workers or whoever is in your company to just directly figure out a way to access and log into your devices that are controlling your grid or your power systems or your conveyor belts, which could lead to a lot of loss of money and a lot of damage if done improperly. So typically you'll see something called a firewall or a DMZ that is going to prevent prevent unauthorized people from accessing these systems. Besides your typical IT business server and network, your phone lines would also be considered a part of the IT system, because it's going to have its own network, but it should not be connected or a part of the operational technology network. Sometimes the DMZ that I talked about, it won't be completely connected, or there won't be any connection at all between the level 4 and the level 3. And this is what you do. This is called air gapping, where the only way to be able to connect to your operational technology network is to be there in person, which is done when you have a high security reason or when you're too lazy to set up connections to your network. So let's talk a little bit about some of the roadblocks to securing operational technology. Well, the big issue is that a lot of these tools, a lot of these protocols, and a lot of the parts of operational technology was designed in the 50s and 60s and 70s, back before none of us existed and the internet didn't exist. Which means that they didn't really think about what happens if someone accesses this technology. Because the only way people could access it was being there in person. And typically they would have their own security guards or their own fences or whatever. But as we evolved along the road, there became a greater need to be able to access these systems remotely, which meant that there would need to be some protections in place to prevent bad actors from accessing it remotely. Some of the, excuse me. So essentially, availability and accessibility would outrank their confidentiality and integrity. If you think of the CIA triad, all they cared about was that it was working and that you could get access to it. They didn't care about whether or not people could read. Allows you to basically do whatever you want as an attacker. So these are a lot of the roadblocks to securing operational technology. What do we do about it? Essentially, how do we stop bad people from being bad? Which is not easy, because bad people, especially smart bad people, can do a whole heck of a lot if you give them enough time and resources. So a lot of the protections that come to securing operational technology is what you would see when you're securing just your standard business network enterprise. You're going to want to put a DMZ, a demilitarized zone, or a firewall between the operational technology and the staff that want to access it. Essentially, this means there's a couple different steps to do this. The first step is that staff will need to access it through a VPN. So just like we try to access the UT Dallas network through a VPN, the staff would need to log on to their VPN to be able to access this network. But once they're through the VPN, they shouldn't get direct access to the operational technology. Rather, they should be on the business side, so the level 4 and the level 5, the business network. And then once they're in the business network, they should use something that's called a jump server to cross over the DMZ and to connect to specific devices in their level 3 system. And you're going to have very specific protections and access roles and groups between users that are trying to access the OT and what devices they can access in the OT. So if you look at this here, at the higher level overview, you have your business, which is going to connect through the VPN to your jump server or your jump host, which is going to be able to connect to specific OT Active Directory devices. So let's go a little more in detail on this. So the first step you'll need to work on is authentication, and this is essentially a problem. So a jump host is essentially a server that you connect to that is used to connect you to other servers. It's kind of weird, I know, but if you've ever SSH'd into your UTD CS1 server and then SSH'd from that server into UTD CS2, you've essentially created your own jump server. And what a jump server does is it's going to be the only server that is able to directly access these OT systems or the SCADA systems. So what you do is you authenticate first to the jump server, and then once you're in the jump server, it's going to check what role you have and give you specific access to specific devices. So if I'm in jump host 1 with my specific role 1, then I'm only able to access these devices managed by role 1. Now if I go to jump host 2 and try to access these devices with role 1, well, I won't be able to access it because jump host 2 doesn't have any way of accessing those devices. Only jump host 1 does. And then say if I had role 2 and I wanted to access the devices hosted by them, then I'd have to go to jump host 2. The reason why you want to do this is it allows for a separation between all the different devices. And this goes back to our idea of if you have 2 factory lines that have different purposes and are not connected to each other in the physical world, then you don't want them to be connected to each other in the digital world. Because if you're able to access them together in the digital world, and that gives the hacker a lot more access to things to break than they would have had otherwise. And last, file transfers, I think is the last part of this, yeah. So a lot of times you're going to need to be able to send files inside and outside of these devices. So if you're coding them, you're going to want to write code on your own device. It's a lot easier that way. But you want to figure out how to get that code into the server, into the device, past the jump host, past the DMZ. Or say you have a bug in some of the PLC code, then you're going to want to have to figure out how to get it out of that so you can use all your debugger tools on your personal system. And this server, and the jump host or the section that contains the jump host will have the same file server or a synchronized file server that has the same read-only and write-only folder. So when you want to read a file, what you're going to do is you're going to follow this yellow line where you send that request through the VPN, it gets authenticated, and you're going to, let's start with write. If you want to write a file, you're going to send that file through the VPN authenticated, and it's going to sit in the write-only file server. And then the write-only file server is going to scan that file, look for any sort of viruses, make sure that it's not malicious, And then once it determines that the file is not malicious and can be used, then it's going to copy that file over to the read-only server, where the host connected to the devices is able to read from that read-only file and place it where needed. And it's the reverse order for taking a file outside of this network, where the host that is connected to the PLCs, it's going to write to the read-only server or the write-only server. It's going to get scanned, make sure that it's allowed out, and then it's finally going to be read by the user outside with their authentication. Now, in a perfect world, you'd have multiple read-only and write-only folders so that not everybody can view the same folder. Only people with the specific permissions to view those devices can write and read to those folders. But the concept of having those read-only and write-only folders is still the same. All right, so what happens if they get past the DMZ, they access the network, and they're able to escalate their privileges? Any guesses? David?
Explosions?
Yes, you're essentially screwed. Since SCADA networks are essentially a network, a specific network, but they're a network, well, once you have access to the network, you're in big trouble. There's not a lot of actual protections made at the level 2 and the level 1 to prevent people from changing the code without it being detected, without it being stopped or preventing it. So the moment that you're compromised, you're in a lot of big trouble. There has been some research done, specifically I know of a paper where they found a way to detect different like anomalous changes in PLC codes or PLC operations that wouldn't normally happen. However, that leads us back to the issue of overhead, where if you're checking these calls or these instructions every time they get sent before they're operated, well, that's going to add some overhead, which means that it's not going to be as fast as it needs to be to complete the task successfully. So a lot of your protection is going to come down to being able to set up your network correctly, making sure that they're segmented, and making sure that if you do lose one, you don't lose any of the others. David?
I don't remember an article or a paper recently stating that once the Linux kernel was pwned, there's nothing you can do. There's nothing you can do to detect, to prevent, to try to stop the attack. Is it kind of a similar deal at an ICS level? Because like, once you have control of the ICS, there's not a whole lot you can do. There's not a whole lot anyone can do to...
They were able to destroy one of their own motors in 2007, but nobody believed that it would ever happen in the wild until it did. And now it's happened multiple times since then. So, let's talk a little bit about how specifically Stuxnet work. At the very high level, it had to first get into the Iranian centrifuge network. And if you know a little bit about the network they had set up, you would know that between their business network, their level 4 and 5, and their OT network, there was no firewall. There was just no connections at all. The only way you're going to be able to access their ICS network was to be able to be there in person and to physically have access to the terminal or the devices that were used in that system, which makes it really hard and really impressive that the hackers, and I'm going to say hackers because no one actually knows who did it, but we all know it was the US and Israel. But the hackers were able to somehow get past these protections and get in the system. So the way that this likely happened, and we know this based off of reverse engineering done on the Stuxnet virus, is that the main method of propagation for this virus was by a USB 0-day. And a 0-day is essentially a vulnerability or attack that is not known by the developers yet, which means that it can be used and there are no ways to stop it because there are no patches to fix it. So it used a 0-day, that is security file transfers, and they put it in and it got into the network. So once it was in the network, it's a worm. It's very smart at traversing the network, making sure that it is able to figure out all the networks on all the devices on the network, and it used a couple of other 0-days, which is really impressive because 0-days are worth like millions of dollars, and if you use more than one for a project, wow, you're rich and you have a lot of money. and you have a lot of time and smart people. On the other, besides that, it was able to get itself pretty entrenched into the network and basically be installed on every Windows systems that was inside of this OT network that was managing the SCADA system. Now, once it's on the SCADA system, it was able to install rootkits. Everyone here know what a rootkit is? So just if you don't, a rootkit is a system that is going to be able to give you your privileges and essentially let you control the device at the kernel level. It's going to have the highest level permissions on that device. And then once it installed that rootkit, it used compromised certificates. And certificates are essentially the way that you verify that a file is valid. So if you're able to compromise a certificate, it means that you're able to compromise the company that provides those certificates, which is another really hard thing to do, which is another thing why that's impressive, but we're not going to get into that. It installed that rootkit, and then it started sending messages back to its command server, looking for updates, seeing if there's any commands, telling the command server if they were able to find what they needed, and so on. And it also was able to be used for industrial espionage because now they're on these devices. Now they have a really good idea of how these devices are working. And say the initial payload doesn't work out, well, they can try again later because they researched and were able to figure out all this information about the Iranian network. So once it was able to get into the network and get onto all these Windows devices, it was ready for the next stage. So it searched all these devices for a specific software called Simian Step 7. Now, when we talked about these SCADA systems and these PLCs, they're going to be controlled by this software. It's a SCADA system software, and it was used to connect the internet, or excuse me, it was used to interact with the centrifuge, where this device would be able to directly connect to the devices running and spinning the centrifuge. Now, they were very particular about what they were doing. So just in case this worm accidentally got onto a random device that just so happened to have Step 7 software, they made sure it was running a specific setting with a specific device so that they knew that they were actually on the system that contained the specific centrifuges that they wanted to attack. Data looked correct once they started conducting their attack. And the bottom level is when they started actually infecting the PLCs. And this is the first time ever where we know of a PLC being directly attacked. A lot of other attacks that have been done since this on physical systems, all they do is they gain access to the SCADA systems that allow you to turn on and off all these devices. And instead of running automated code that would make changes to it, they just take control of the system using their rootkit, and they manually move the mouse over the web and click the button that turns it off. But this is really cool because they wrote their own PLC code, and they injected this PLC code into the PLC. And reminder, the PLC is going to be the thing that's controlling all these motors, these sensors, these conveyor belts. And in this instance, this PLC code, or this PLC, was controlling the speed that the centrifuge was spinning at. And what they were able to do is they'd make it spin really fast, and then way too slow, and then really fast again. And that would be outside of the normal operating system of the centrifuge, because it was supposed to be operating at a pretty consistent level the entire time. And they'd do this for like 4 minutes, 5 minutes, and then they'd take a 2-week break. Then they'd do it for a day, then they'd take another break. And as they kept on doing this, the lifespan of these centrifuges were drastically decreased. And there was one report that said they likely lost over 1/5 of their centrifuges just to this attack, drastically setting back the timeline of the Iranian nuclear program, because now they're no longer able to make their uranium as well. I don't remember the process for it. I'm not a uranium guy. They weren't able to do their uranium thing in the centrifuge thing, I don't know, for a while. But what's really cool about this, again, is that they were writing direct code to the PLC to break this system, to cause physical damage, which had never been seen before and has only been seen a couple of times since then. Yes.
There's some like open centrifuge standard for writing PLC code. Like, how do they know what to replace? How do they know where to put the?
Be it the CIA or the NSA, they have some really damn good intelligence to where they were able to know exactly what the software and physical components were, to where they likely had their own lab set up inside of their building or whatever, to where they could test it themselves and make sure that the code they wrote is going to be correct, which is really cool and a ton of money to do that.
And if you get it wrong, like, it's a game over.
Pretty much. If they got it wrong, then well, they did make some updates because they had that command and control center. But if they got it wrong so bad to where they got caught, then it is game over, which they did eventually get caught. I didn't write a slide on this, but this is actually kind of cool. Where when they got caught, the reason they got caught is because they sent this virus to a bunch of different companies that they believe worked with the Iranian program in order to get it onto this, onto the drives of these engineers that are connecting to the program. And what happened was it started causing weird crashes or weird faults in other systems, in even like home systems of people in Pakistan or people in Iran, and it was even found in some systems in the United States. Now it was usually pretty benign because again it checked to make sure that it only had those specific PLC software installed, but there was still some weird issues that would cause it to break and cause it to crash. And after a lot of investigation, a couple of teams were able to figure out that it was related to very specific files that was causing the crash. And eventually they did a lot of digging and a lot of research, and we figured out, oh, this is a really sophisticated cyber weapon that we've never seen before and that we're going to write books about. And they did. And that's how we know about Stuxnet, is because it started crashing some people's Windows devices.
Have we confirmed if the NSA was involved?
Nope.
This is the point where you say NSA was definitely not involved. You know, as long as we want them to come over here.
Hey,
like
they did it. I'm going to say it now. It was NSA in Israel, Unit 8200. This is the only people that could have done it. So the impact, it's claimed to have destroyed over a fifth of all of Iran's centrifuges. And again, it's the first well-known of a cyber attack that caused damage. And it still remains probably the most sophisticated example of it that we know of. I bet you there's something more sophisticated that we don't know of. So, that was one example of attack. I'm going to use a little more recent example now that is also pretty relevant to today. Because as of like a week ago, now a third of the Ukrainian grid, they said, screw it, we're going to ignore all this cyber stuff and just bomb it. So I have some theories on this that nobody has actually talked about online, but I think might be a cool thing to look into. But starting in 2015, the Ukrainian grid started getting attacked by cyber attacks. And over the years, they've gotten more and more impressive. So the first example of this was in 2015 called Black Energy. And it's the first known successful example of an attack on a power grid. And after that, they came out with the Indestroyer attack in 2016, also called Crash Override. And this is the first known example of using malware specifically targeting PLC systems, SCADA networks, to be able to destroy these grids. And then last was Indestroyer version 2, which we actually saw the first example of this in April, I think, of this year, where they have significantly improved the malware that they created to be able to target these grid systems and just any sort of SCADA system in general. And we'll go a little bit more detail into that now. So the 2015 attack using Black Energy, this was a general Trojan horse used by Russian APT Sandworm. And an APT stands for an Advanced Persistent Threat. You can think of it as very hardcore, dedicated hacking groups that are able to use their resources very effectively and very targeted. There's names for them. The intelligence community does a lot of research into how the different ways that these groups work. And the one that is doing these grid attacks is known as Sandworm. They're most likely Russian, but nobody can confirm it. And the way that they were able to perform this attack is called spear phishing. Spear phishing is like phishing. If anybody knows phishing attack, it's your typical Nigerian prince attacks where they're like, oh, give me money, please. But in spear phishing, instead of doing a very wide attack, what you're going to do is you're going to pick a person. So I'm going to pick Charles, and I'm going to research everything I know about him, and then craft a very specific email to him so that he's going to click on that link, and he's going to be a fool.
What's
So,
that gonna be like? What would the subject line be for Charles?
I have to do some research. We can brainstorm it next Monday. But in general, they picked a fool, and they got him. And they got access to the network. Once they were in the network, they were able to use Black Energy, which is a very well-known malware Trojan horse rootkit at that time, and they were able to just get access to those Windows systems controlling SCADA. Now, it was pretty lowball because all they did is they took the mouse control of these SCADA systems all at once and then pressed the off button and overwrote all the files and called it a day. But still, that shut down it shut down a 250,000 people's grid in Ukraine for 1 to 6 hours, which is very significant and very scary. Now, the computer systems, while they were able to turn it on quite quickly and bring the power back, since they overwrote all these computer system files, those took months to restore because they had to completely reset their SCADA system ICS infrastructure, and everything they were doing for a while there was showing up manually in person and pulling the switches, pressing the buttons manually instead of doing it by a computer. So it was very effective and very destructive at the time. Come a year later, they tried again. Now, this one wasn't as successful, but it was way more sophisticated when you looked into it. They used what is dubbed in destroyer by researchers, or another research group calls it crash override. And it was the first one that tried to cause actual physical damages to these components and switches. Now, when they caused the attack, they did the same thing. They turned all the turn-off buttons, they shut it down, and they caused it to go down for an hour. But they did something really cool where they were able to they overwrote a specific device, and this successfully occur would have taken a much longer time to fix, but they could have turned it on just manually. Well, they thought about that. The other thing they tried to do was they opened a very weird, I don't know exactly what it's called, but basically what they opened was a protection device, and the protection device would look for weird fluctuations in the energy and see if there's any issues, and if there's something like the electricity is too strong that's going to melt the wires, then it would shut it off immediately. Well, they made sure that all these were, their goal was to make sure that all these were off, and that when the Ukrainian power people tried to turn it back on immediately, well, that would cause a surge in energy that would cause physical damage to all these wires, and the breakers there to stop it wouldn't be working anymore. The reason why this didn't work is because they set it to a delay, where after they wiped everything and turned everything off, those breakers weren't going to be turned off for about an hour, and the reason why they did that is unknown still, but I believe they thought that the Ukrainian power people wouldn't be able to turn it on as fast as they did, and they probably thought it would have taken 6 hours again for the majority of these, hence allowing the damage to go through. And given that the Ukrainian people were ready and prepared, they were able to turn it on quick enough to where these protection components were not able to successfully break and and cause the actual physical devices to break. And this is the second, this is the third, there's a Saudi attack, but this is the third instance ever known where a malware was attempting to cause physical damage to infrastructure. Now, the really scary thing about this, go ahead.
What is a data historian?
The what? Data historian? That's the part of your SCADA system that's going to be tracking all the data. So it could be your groups, it could just be taking all the data, like measurements from these systems and keeping track of it for all the other devices to know. Think of it as a database for the network.
You know how they compromise that?
I don't. I didn't do much research on that. I believe it's the same way where they, once they were in the SCADA network and they had access to those devices, they were able to connect to the data historian and access that as well.
Did they like spearfish someone again?
Say that again?
Did they spearfish someone again?
So they spearphished someone to get access to the SCADA system. They got his credentials, and I guess he had too much access. They had basically total access to the OT system. And inside that OT system was the data historian. So if we go back to this, they spearphished and were able to get basically control of level 3 and down. And your data historian, that's going to be in level 3. Yeah, but really cool attack. Third example of it. The very scary thing about it is that the United States grid, in a lot of ways, is actually less rules to these devices to be able to cause different ways of destroying them, to hurt them once the malware is in their system. Which means that there's a lot of greater sophistication of this and a lot more things that they likely can do with this. So given that as of this week, Russia has gone full gung-ho on just destroying the Ukrainian grid by conventional means, why did they even bother using a hack against the Ukrainian grid? Now this is where I put on my tinfoil hat, because I didn't actually research or look into why this happened. I truly believe that this is a test for them. That since they're in an example of actual war, and they can likely justify in their minds causing these grid attacks, these are probably tests to where they can further improve in Destroyer to be able to cause attacks on not just the Ukrainian grid, but if the time comes, any other grid, any other industrial system that they please, which is really scary, and I think is something that we need to do more research in. So if you're really cool and you want to learn more about this, read everything here. It's really fascinating. I think this is kind of the coolest area in cybersecurity right now.
You gonna put these links on Discord?
Yeah, I'll put I'll put the whole slide on Discord if you want, but it's a really cool area. There's not a lot of work that's being done into it right now, but it's something that I think will become more and more necessary as time goes on, and something that is a potential career opportunity for anyone in this room. Are there any questions? All right then, thank you for coming. Appreciate it.